Do you ever feel like you're out of place? Well, we're about to do the 2021 AMC 10B problem 1, which was also the 12B problem 1. I hope you guys enjoyed it, but sometimes you might have felt like you were out of place, which is why you'd be lucky to have a quantum marker. You see, with the quantum marker, I can simply toss the marker up, and there it is. I'm over here. The quantum marker has allowed me to teleport. And so if you ever found yourself out of place on this test, I bet you wish you had a quantum marker. Let's get started. Well, what is my prediction for how the AMC 10B how it went? What was my Amy cutoff? You know, I don't really know. I had a tough time. Initially, I kind of thought it would be a little lower than the A because I felt there was a few trap answers in here that were pretty darn good, like number 2, which we'll get to. And, you know, I don't know, but now I'm kind of feeling like maybe a little higher. Maybe 111 again, right around there. I don't know. Hard to say. Hard to predict for me after this one. I didn't get a good feel for it. I have no predictions on the 12. Sorry, guys. Can't tell you. I have no percent chances of each one qualifying. We're all going to have to wait and see. But if you did want to know direct answers, you can go to AOPS forums when these videos are posted, and somebody will have posted a answer key thread. And they usually talk about those things and get it all figured out. And they're pretty reliable answers after about an hour when there's some discussion has occurred. So if you want to know if you wrote your answers down and you want to know if you got them right, you can go there first rather than skipping through all my videos to see what answers I got. But besides that, let's get to this problem. How many integer values of x satisfy the absolute value of x less than 3 pi? Good to memorize pi, 3.14, right? Everybody knows that. So 3 times 3.14 is 9.42, and you're looking for the absolute value of x to be less than that. It's obviously everything from -9 to 9. You could either think of 9 positive, 9 negative, and 0, and get 19, or you could use the formula b minus a plus 1, which would be 9 minus -9, which is 18, plus 1, 19, get d, and let's get on to problem 2. And here we are continuing with the 2021 AMC 10B problem 4. It was also the 12B problem 2, and it's time to make up for some lost time, at least it was for me. Luckily, this problem directly connects to another problem, and that is the 2001, shockingly enough, AMC 8 problem 24. If you had ever done most of the old AMC 8s, or maybe you were younger at that time and did this when you were practicing for the AMC 8, you might recall this problem. I'm not going to go through the whole thing, but basically there was a triangle above and it had equilateral triangles on it, like this, and it folded down, or something like that, or diamonds or something, I think triangles. And you folded it down, some were red, some were blue, some were white, or something like that, and you had to make pairs of them. Well, the strategy that I use in solving that problem when I teach my students is the same one we're about to use now. So this again is why we want to know all the historical problems, because they contribute to how fast you can do modern day problems. Let's go. At a math contest, 57 students are wearing blue shirts, and another 75 students are wearing yellow. Pause. 132. Good. It tells us that there are 132 students, and there's going to be 57 for blue, and there's going to be yellow 75. The 132 students are assigned into 66 pairs of students, kind of like pairing the triangles. In exactly 23 of these pairs, both students are wearing blue shirts. So that would be like the BB pair if I've got 23 of these pairs, not 23 students. That would be weird because you can't have whatever. But 23 pairs of students, that's 46 students. So 46 students are going to be a double blue. What does it mean? It means 11 are not a double blue. And as a result, those 11 must be paired with someone, and there's only blue and yellow to go by. And so it must be that they are paired with a yellow-shirted individual. So if there's 11 of these, what does it mean? It means on the other side, 11 of these yellow are going to be paired with blue because these are the same pair right here. They're part of the same group, blue and yellow mixed together, right? And so then that means if I take 75 minus 11, there will be how many students? 64 students, not pairs, 64. But if you didn't catch that, they are so happy to oblige and give you 60. Good job, you got 64. Sorry, I hope that didn't happen to you, but that is a little risky. It's not as bad as the trap on 2 in my opinion, but it is a pretty good trap because you know this is something significant, and because it's so significant, we sometimes get a little, oh, I've got to finish faster, and we might make a mistake there. Probably you didn't, but you might have, and sorry if you did. So, what are we looking for? Keep going. In how many pairs, and how many pairs, not how many students, are both students wearing yellow shirts? If there's 64 students in yellow pairs, there must be 32 pairs. And that's the answer, 32 pairs of students wearing yellow. Go look this problem up. Think about how we did this with the pairing like this. Do that one in a similar way. It'll go a lot faster in my opinion if you think about it that way. See you guys in the next problem. All right, so now we're going to be doing the 2021 AMC 12B problem number 3. Suppose is true, then it's equal to this, and none of that looks fun. What is the value of x? There's probably some fancy schmancy nested function kind of thing you can do, but that's kind of mentally taxing to rack your brain thinking of it. Why don't we just solve it the normal way? So minus 2 minus 2. Instead of minusing 2 over here, we'll do 106 over 53. Why did I do that? Because why combine it here? It's going to make this easier to work with. So 144 minus 106 is going to be what? 38? Yeah, 38. So this will be 38 over 53. Okay, then what? Let's do this part here. I'm just going to focus right here, and we're going to multiply this 2 by this denominator, and you'll do 2 times 3 plus x, which is 6 plus 2x over 3 plus x, plus another 2 over 3 plus x, right? So there's this 2, numerator and denominator by this. We're going to add this up now. We're going to get 2x plus 8 over x plus 3. I always felt more comfortable with the x's on the left. All right, then we got 1 over this, so it's basically a reciprocal, and then we're going to add 1 to it. So we're going to have reciprocal x plus 3 over 2x plus 8. And since we're going to add 1 and we don't really want to add 1, we want to add this denominator, numerator, and denominator just like it. Basically a form of 1 that's equivalent to it. And so when we do that, we're going to get 3x plus 11 over 2x plus 8. Okay, and then there's a 1, this is gone. There's a 1 over this expression, which means we want the reciprocal of this. So we're going to have, I'm just going to reciprocal this, 2x plus 8 over 3x plus 11 is equal to 38 over 53. From this point, you're going to cross multiply. That's what you do when fractions equal fractions. So 53 times 2 is 106x plus 424 is going to equal 3 times 38. That'll be 90, and 24 is 114. 114x, and then 11 times 38 is going to be 8, 1, and then you bump it up, 418. I should leave more space there. Didn't leave enough space for the plus sign, so plus 418. So what do we do there? There's an 11's trick for multiplying. You can take the 3 and the 8 and add them and get 11. You'll put this one in between them, and this one gets added there. So it's 418. So we're going to move the 418 over here to get 6, and the 106x over here to get 1, or not 108, just to get 8x is all you're going to have. Nothing there. And then 6 divided by 8x is going to equal 3/4. Wow, that was fun. Okay, not so fun. But you have to get it done. You should know how to do this. It's pretty, I don't know, standard kind of problem. So let's get to problem 4. All right, so here we are continuing again on the 2021 AMC 10B problem 6. It was also the 12B problem 4. Miss Blackwell gives an exam to 2 classes. The mean scores, which is just average, of the students in the morning class is 84. Don't read on, make sense of what you're reading. So my preferred formula for averages is the sum of subscript n divided by n equals the average subscript n. Now you don't always write this. Sometimes you'll put a number, like in this case here. We're going to do the sum of the morning classes, sum m, divided by m being the number of students in the morning class. This is going to equal 84, and immediately multiplied to get that the sum of the m students is 84m. That's typically what you'll do with this every time, is immediately multiply by this. And the afternoon class's mean score is 70. So again, this time we're not going to actually write the A underneath because we anticipate multiplying by it. And just to save time, right? The ratio of the number of students in the morning class to the number of students in the afternoon class, so m over A equals 3/4. I'm just going to multiply by A. So m is 3/4 of A. We want to know the mean scores of all the students. Well, think about how would the mean be calculated? It would be the sum of the morning class plus the sum of the afternoon class divided by the number of students in the morning and the afternoon class. That's the average. We just need to find it. And the problem is we've got 2 variables and they're written in terms of a sum. So what do? We know that the 84m is here, but we see that m is 3/4 of A. Well, pretty good then. All we got to do is replace this m with 3/4 of A. You should recognize 84 is 21 times 4, and then 3 times 21 is 63. So if I replace the m with 3/4 of A. Again, you're putting the 4 into the 84 to get 21 times 3, 63A. And then you're going to put that in place of the sum of m now, because this was the sum of m. So you'll have 63A plus sum of A, which we know is 70A, over, it's going to be 3/4 of A plus A. You should get 7/4 A. Well, look at that. The A's all cancel. And now we're going to have, actually, I'm just going to multiply. It's basically the sum of this times, or divided by 7/4 is going to equal 63 plus 70 times 4/7. I didn't actually want to add, even though it's not bad. I don't know. I just saw the 7 goes into here really easily and into here 10 times. Most of you probably know that 133 divided by 7 is 19, but if you don't, sometimes it's easier to cancel when you haven't added it up yet. So 19 times 4, answer is going to be 76. Let's get the next problem. Here we are on the 2021 AMC 10B problem 9. It was also the 12B problem 5. Transformations in the plane, here we come. The point PAB in the XY plane is first rotated counterclockwise by 90 degrees around the point 1,5 and then reflected about the line y equals -x. We don't quite know maybe what to do with that. You probably could. If you memorized your transformations, you're good, but this doesn't take that long to just figure it out. Let's see what we're talking about. The image of P after these 2 transformations is -6, 3. What is B minus A? Okay, so what we're going to do, I'm going to do anyway, is this. If you fold over -6, 3, okay, and you're here, and you just, I'm going to go in reverse. You just finished folding over the line y equals -x. That's a really easy transformation to do. In fact, it's one of the only 2 that I actually remember, that one and y equals x. I mean, I commit to memory. You might want to memorize the 90 degrees counterclockwise one too. But to flip something or reflect it over this line is simply to switch and negate. Why? Because literally y is really negative x. And since x is negative 6, the new point y will be positive 6, the negative version of x. And since x would be negative y if I moved it over, the 3 is going to become negative 3. That's worth remembering if you didn't want to graph it, although this takes maybe 30 seconds more time by drawing a quick sketch to be sure of your answer. The next thing is it's going to rotate. Oh, this is why you can't use the counterclockwise rotation rule about 1/5. Maybe you can. There's probably some fancy schmancy, super smart way that you can do it if you're huge-brained. But for people like me and perhaps you, it's better to just think, okay, here's 1/5. If I'm going to rotate 90 degrees about that point, then counterclockwise would be this way. It's going to go up here, and this needs to be 90 degrees. Well, how does that work? They're perpendicular lines. We can do negative reciprocal slopes. So if I look at the slope from here to here, I'm going down 1, that's negative 1, and negative 3 to 1, you're increasing by 4. So your slope is down 1 over 4, which means the other negative reciprocal slope needs to be the negative reciprocal, 4. So if you're at this point, you're going to go up 4 and 1 to the right. You're going to be 1 to the right at 2, up 4 at 9. What is b minus a? B was the y, a was the x. 9 minus 2 is 7. We got d. Didn't take that long. You don't have to know any complicated formulas to do it. You can just figure it out. Incidentally, one more thing to point out is if you reflect like a point over the line y equals x, literally, y equals x. This would become, for instance, 9, 2 if you reflected it over y equal, because y is x and x is y. That's how that works. That's why I memorized those ones, because they're literally so simple to recall. But rotations and stuff, I don't know, you can usually figure it out with a little bit of ingenuity. Let's get to problem 10 for AMC 10B and problem 6 for the 12B.